Hello and welcome again to another session of Learning Together with the Brosis Foundation. We are so delighted to have another privilege to share with you some experience, some knowledge in math. Today is going to be balanced. A part of it is going to be pretty simple and a part is going to be a little bit more complex. But put it all together, it's going to be a nice session. We have been working with matrices, and last time we were together, we discussed how to solve systems of equations using matrices, using the inverse matrix. Today, I'm going to show you another aspect of using matrices, namely using the Cramer's rule to solve systems of equations. So, first, I'll start by looking at a system of equations with two variables. We're going to solve so we know what the answers should be. Then we're going to use Cramer's rule and hopefully we'll get the same answer. Okay? So let's go. It says here 2x plus 3y equal to 10 and negative 3x plus y equal to 7. So this is equation 1. This is equation 2. In order to solve these two equations, I realize that I can't just combine as is. So I'm going to multiply this equation by negative 3. So I can add a 3y and a negative 3y. So here we go. Equation 2 multiplied by negative 3 gives me 9x minus 3y equals to negative 21. Call that equation 3. I'm going to write equation 1 just below it, so it's in close proximity. Notice I didn't change the equation, I just changed the location. So it is close to equation 3. Now, if I add equation 3 and equation 1, what do we notice happen? 9x plus 2x is 11x. This and this cancel, and we end up equal to negative 11, which gives us x is equal to negative 1. So we have discovered that one solution is x equal to negative 1. So now, I'm going to go to equation 1 and plug in for x so that I can find y. So here we go. So using equation 1, I have 2 times x plus 3y is equal to 10. That is negative 2 plus 3y is equal to 10. So 3y is 12. So y is equal to 4. So we're seeing here that x is equal to negative 1. Y is equal to 4. Those are our two solutions based on what I've just done. So what we could do is we could check to see if these are correct. Let's go. 2 times negative 1, negative 2. 3 times 4, positive 12. Negative 2 plus 12, 10. So that works perfectly. Negative 3 times negative 1 is 3. Plus 4 gives you 7. So we see that it works. Okay. So now we're going to introduce you to Cramer's rule. We know the solutions exist, and we're going to try and see if Cramer's rule can actually give us the same answers. So, basically, what Cramer's rule says is that the solutions can be obtained for this system of equations by just using the determinant of 2 by 2 matrices. So here we go. So this is 2, 3, negative 3, 1 times xy equals to 10, 7. So that is the matrix equation for this system right here. We have the matrix of coefficients 2, 3, negative 3, 1. That's the matrix of coefficients. This is the matrix of variables, and this is the matrix of constants, okay? And what Cramer's rule says is that we need to find 3 determinants. Yes, I said 3. One is the determinant of the original matrix, which is this, and then we'll go find 2 other. So let's go for the first one. So the determinant of 2, 3, negative 3, 1. Remember I said if we use the vertical lines, that's for determinant. It's going to be equal to 2 times 1 minus 3 times negative 3. And this gives me negative 3 times negative 3 is positive 9 plus 11 plus 2 gives me 11. So that takes care of the matrix, the determinant of the original matrix. Now, we need to find, let's call this, call this D. We need to find dx. Dx is a determinant that is obtained by taking the column that involves the coefficients of x, 2 and negative 3, and replacing that column with the constants 10 and 7. And then we now have a 2 by 2, find the determinant of that matrix. So we go, it's 10, 7. This remains the same because these are y's. When we find the determinant of this, it becomes 10 times 1 minus 3 times 7. And what does that equal to? 10 times 1 is 10, 3 times 7 is 21. So it's 10 minus 21 gives me negative 11. Now I need to find dy. I guess by now you know that dy is going to be the determinant of the matrix here, the original matrix, except that the y coefficients are replaced with the constants. So we go back, we write the 2 and the negative 3, but instead of 3, 1, we write 10, 7. Now, the determinant of this is 2 times 7 minus 10 times negative 3. 10 times negative 3. So it's a minus minus, so it's 14 minus, let's see if we can make sure we get this clear. So it's 10, 7, 2, negative 3. So 2 times 7, 2 times 7 minus 10 times negative 3. So that gives us negative 10 times negative 3 is 30, plus 14 gives me 44. And the final answer is, according to Cramer's rule, is that x is going to be equal to dx divided by d. So you say dx is negative 11 divided by d, which is 11, gives me negative 1. And y is going to be equal to dy divided by d. What is dy? dy is 44 divided by d, which is 11. 44 divided by 11 gives me 4. And those were the 2 answers we're looking for. Negative 1, positive 4. Okay? So the first example was to demonstrate the steps. Now I'm going to do another one, and we can move a little smoother so you can see the steps coming into play. And then we'll move on to the 3 by 3. So let's look at another question. How about 2x plus 5y equal and 3x minus y equal. Okay? Okay, so these are my two equations. And we're going to see if the Cramer's rule work. So the matrix equation would be 2, 5, 3, negative 1 times xy equal to 15, 14. That's our matrix equation. So D is going to be the determinant of the original. And remember, we said that the determinant for the 2 by 2 is AD minus BC. So it's going to be 2 times negative 1 minus 5 times 3 equal to negative 2 minus 15. That gives me negative 17. And you double check to make sure we're good. 2 times negative 1 minus 15, negative 17. Good. So now we go for dx. For dx, I replace the x coefficients. The x coefficients 2 and 3 with 15 and 14. 15 and 14. The y coefficients remain the same. And that's going to be equal to 15 times negative 1 minus 5 times 14 equal to what? 15 times negative 1 is negative 15 minus 70 equal to negative 85. dy, again, we take the original matrix and replace the column that involves the coefficients of y, which should be 5, negative 1. Replace that column with the constants 15, 14. So now we have 2, 3, 15, 14. 2 times 14 minus 15 times 3. 2 times 14 is 28 minus 45. Let's double check. 28 minus 45. What does that give us? That looks like it's giving me negative 17. And according to Cramer's rule says x is going to be equal to dx divided by d. What is dx? dx is negative 85 divided by d, which is negative 17. And that's equal to 5. Okay? According to Cramer's rule, y is equal to dy divided by d. And that's going to be equal to, what is dy? It's negative 17. And what is d? Negative 17. And that's equal to 1. So we're seeing that x is equal to 5, y is equal to 1. So we write x equal to 5, y equal to 1. So any good student would want to check to make sure that the answers make sense. So we're going to go plug in 5 for x and 1 for y. 2 times 5, 10. 5 times 1, 5. 10 plus 5, 15. Yes. 3 times 5, 15. Take away 1, 14. Perfect. So now you have Cramer's rule in your bag. What is Cramer's rule? Cramer's rule is solving a systems of equation by using strictly determinants from the coefficient, from the matrix of coefficients. Okay? So that's what Cramer's rule is. So that is supposed to be the easy part of what we have to do today. Now we go to the 3x3 matrix. You need to put your seatbelts on. Okay? Here we go. Every now and again, I like to put a little rigor into the concepts that we're presenting. So we have a blend of not so difficult and also a little bit more difficult. So now we're going to do something that's a little bit more difficult. However, before I do, I just want to recap how to find the inverse of a 2x2 matrix. I'm going to recap that. So we said that if A is the matrix A, B, C, D, we said that to find the inverse matrix, which is A minus 1, we first have to find the determinant of A, and we discover that the determinant of A is equal to A, B minus B, C. The determinant of A is this times this, AB minus B times C. If this is 0, you stop. It means that the inverse matrix does not exist. Okay? Then you take that number and you multiply the reciprocal. That is 1 over AD minus BC times. And what we do now is we take these two and we switch them around. All of this is a review of the previous session. We take these two and they switch places. So D comes here and A goes there. Then we take these two and we switch signs. And that's how we find the inverse of a 2x2 matrix. Okay? So it's basically 2 steps. Find the determinant, then do a little switch right, well, 3 steps. Do a little juggle inside the matrix, and then finally multiply by the reciprocal of the determinant. And that's it. Unfortunately, finding the inverse of a 3x3 is not as straightforward. Now, one of the things that we also discussed is how you could check if your answer is correct. How do you know that this is the inverse of that? And vice versa. Well, we discovered that if the two of them are inverses, then you can actually flip the order and the result is the same. And we also discovered that when you multiply them, you get the identity matrix. So in this case, if it's a 2x2, you get the 2x2 identity matrix. We call it I2. Similarly, if it was a 3x3 matrix, you would end up with the I3. And I3 looks like this. This is a pattern. And of course, by now, by deduction, you can see that if I went to I4, it would be something very similar with all 0 entries except in the column from top left to bottom right will all be 1s. Okay? So that's a unit, not a unit, sorry, that's the identity, the multiplicative identity matrix. Okay? So now we're ready to go check out the inverse of a 3x3 matrix. Okay, what I'm going to do is this. I'm going to sort of work through the back door, okay? And I want you to stay with me because, again, it's going to be a little rocky. First of all, I'm going to give you two matrices, and we're going to check to see if they're inverses. And then what we're going to do now is we're going to take one and do the steps and see if we end up with the other. Got it? So here we go. If I gave you 0, -3, -2, 1, -4, -2, and -3, 4, 1. And we're saying that 4, -5, -2, and 5, -6, -2, and -8, 9, and 3. These, let's go double check to make sure the numbers are correct. 0, -3, -2, 1, -4, -2, -3, 4, 1. Okay, and then this is 4, -5, -2, 5, -6, -2, -8, 9, 3. Okay, so let's go. Okay, let's double check to see if this will give me the identity matrix when I multiply. So it's going to be row times column. This is a 3 by 3, this is a 3 by 3. So we must get a 3 by 3. So you have to stay with me because this is row times column. So 0 times 4 is 0. -3 times 5, -15. -2 times -8 is 16. When we add 0, -15, and 16, we end up with 1. Okay, 0 times 4 is 0, plus -3 times 5 is -15, plus -2 times -8 is +16. That gives me 1. Now, this is the 1, 2 entry. So it's the first row, second column. So 0 times -5 is 0. -3 times -6 is 18. And then -2 times 9 is -18. That you see is 0. Let's go to this. This is the 1, 3 entry, first row, third column. 0 times -2, 0. -3 times -2, 6. And -2 times 3, -6. So that you see gives you 0. So that's a great start. The first row looks beautiful. Let's go to the second row. So this is going to be 2, 1 entry, second row, first column. Second row, first column. 1 times 4, 4. -4 times -4 times 5 is -20. And -2 times -8 is going to give me 16. Let's go again. 1 times 4 is 4. -4 times 5, -20. -2 times -8, +16. 4 plus 16, 20. Take away 20 is 0. Now we're going to go to the 2, 2. Second row, second column. 1 times -5, -5. -4 times -6, 24. And -2 times 9, -18. Okay. -5 minus 18, -23. Plus 24 is 1. Okay. Now we go to the 2, 3. Second row, third column. 1 times -2, -2. -4 times -2, 8. And -2 times 3, -6. -2 minus 6, -8 plus 8 is 0. So far, so good. 6 down, 3 to go. We're going to use this section right here. So now it's a 3, 1 entries, the third row, first column. -3 times 4, -12. 4 times 5, 20. 1 times -8, -8. So -12 minus 8, -20, plus 20 is 0. Now this is the 3, 2 entry, third row, second column. -3 times -5, 15. 4 times -6, -24. 1 times 9 is +9. So 15 plus 9 is 24. Take away 24 is 0. 1 to go. Third row, third column. Third row, third column. So we go. -3 times -2 is 6. 4 times -2 is -8. 1 times 3 is 3. 6 plus 3 is 9. Take away 8 is 1. So we realize that when we multiply this times that, we get the identity matrix. And I strongly believe that if we flip it around, we'll get the same thing. But in the interest of time, I'm going to go now into finding the inverse matrix by using one of them. So if I use this, I should end up with that. Or if I use this, I should end up with this. Okay? Okay. What I'm going to do is I'm going to use the first one. So I'm not going to have enough space. Okay. So what I'm going to do, I'm going to write these down. I'm going to copy these two matrices. So 0, -3, -2, 1, -4, -2, and -3, 4, and 1. The other one is 4, 5, -8, -5, -6, and 9, and -2, -2, and 3. Okay, so what I've done is that I've copied the two matrices, and I'm going to work with just one and see if I get the other one. Okay, so step 1 says find the determinant of the matrix. Because remember, if the determinant is 0, you stop because game over. The inverse does not exist. So the first step is to find the determinant. Now we found the determinant of a 2 by 2, saying it's AD minus BC. Now this is a 3 by 3, and the way you find the determinant of this is you take this number, and you're going to cross out this row, cross out this column. So you end up with these 4 items right here. And you're going to find the determinant of this is -4, -2, 4, 1. Then it's going to be minus. So the minus, cross this column out and this row, cross out this column, this row, so you're left with 1, -2, 1, -2, and -3, 1. And finally, it's a plus. -2, cross out this column, cross out this row, we end up with 1, -4, -3, 4. Let's simplify that and see what we end up with. So the determinant is equal to 0 times, well, this is going to be 0 because you're multiplying by 0, but let's finish it. It's -4 plus 8. And then this is minus minus, so it's going to be +3 times 1 minus 6. And then -2 times 4 minus 12. What's that equal to? This is 0. 1 take away 6 is -5, so it's -15. And then this is -8 times -2 gives me +16. So I end up with determinant of 1. Okay, determinant of 1. So what does that mean? It means that the determinant exists, it's not 0, so therefore the inverse exists. So now I'm going to put the determinant somewhere. Determinant is equal to 1. But that's going to be needed in the last step. Okay? So again, I need a space to work with, so here we go. Now, there are a total of 5 steps. We have just done 1 step, okay? The other 4 steps, the order is not really important. So in one representation, you're going to see a certain order. In another representation, you will see the order change, okay? So don't get confused by the changes in order. So I'm not sure which one you might see when you go online. But what is important is that the order is not important, okay? Got it. Okay, so what I'm going to do now is I'm going to transpose this matrix. What does it mean to transpose? To transpose means that the first row becomes the first column. The second row becomes the second column. The third row becomes the third column. So let's suppose we call this matrix A. So A transpose is equal to, so the first row becomes the first column, so 0, -3, -2. The second row becomes this second column, 1, -4, -2. The third row becomes the third column, -3, 4, 1. So now we have completed the second step, so 3 steps to go, okay? Now, the next step is to multiply this matrix by this pattern here, pattern of pluses and minuses. So we're going to multiply this by this, and so we end up with the, let's see. Should we do that right now? Before we do that, let's do the matrix of minor. Let's do this one first. Before we do this, each entry, we have a total of 9 entries. If you take the entry right here, there's going to be what is called a minor. The minor is what is created by canceling this row, canceling this column, and finding the determinant of what is left. So that's going to give me the first entry. Then for the second entry, cancel this column, cancel this row, and do what we do right here. I did it before, but I didn't save it, so I'm going to have to do it all over. So the matrix of minor. Matrix of minors is going to be equal to, okay, so here we go. So when I take this one, so I'm going to be left with, I'm going to need the space, so I'm going to show what happens. So this one, cross out this, cross that out, so I'm left with -4, 4, -2, 1. So -4 times 1, -4, minus 4 times -2, negative 8. So what does that equal to? That's equal to 4. So again, when you cross out this column, cross out this row, we're left with negative 4 times 1, negative 4, minus 4 times negative 2, negative 8. So we get 4, so we put 4 in this position. So we come to this position right here now. So we're done with this. We're in this position. So this position, we cross out this row, cross out this column. So we're left with negative 3, 4, negative 2, 1. Again, we cross out this column, cross out this row. Negative 3 times 1, 4 times negative 2. Negative 3, 1, 4 times negative 2. That gives me negative 3 plus 8 equal to 5. Let's double check. Plus 8 gives me 5. So this entry is 5. So now we finish with the second. We go to this one. Cross out this column, cross out this row. What are we left with? We're left with negative 3, negative 4, negative 2, negative 2. Negative 3, negative 4, negative 2, negative 2. So this times this gives me 6 minus this times this gives me 8. So that gives me negative 2. So we're finished with the first row. Now we're going to go to the second row. And the process is the same. Process is the same. So now we're going to cross out this row, cross out this column, so we end up with 1, negative 3, negative 2, 1. Cross out this row, cross out this column, we're left with 1, negative 3, negative 2, 1. What does that give us? 1 times 1 is 1, and 2 times 3 is 6, so it's 1 minus 6 gives me negative 5. Let's go to the next one. We're going to cross out this row, cross out this column. Cross out this row, this column, sorry, cross out this row. So we're left with 0, negative 3, negative 2, 1. 0 times 1 is 0, minus 3 times 2 is 6. It's negative 6. Then we're down to this one right here. Cross out this row, cross out this column. This row, this column, so we end up with 0, 1, negative 2, negative 2. 0 times negative 2 is 0. 1 times negative 2 is negative 2, so it's minus negative 2, so is equal to positive 2. Now we go to the third row. Again, this is called the matrix of minors. Okay, here we go. With this entry, we cross out this row, this column. So we're left with 1, negative 3, negative 4, 4. What does that equal to? 1 times 4 is 4, minus negative 3 times negative 4 is 12. 4 take away 12 is negative 8. And over here, cross this out, cross that out. Okay, so what are we left with? We cross this out, cross that out, we're left with 0, negative 3, and negative 3, 4. So 0 times 4, 0. Minus negative 3 times negative 3, 9. And finally, We're here. So this is the one we're working on now. So now we cross this row out, cross this column out. We have 0, 1, -3, -4. 0 times -4, 0. 1 times -3. 0 take away -3 is 3. This is our matrix of minors. So now we're going to multiply. So this is our step number 3. Okay? So now we're going to multiply this by our negative and positive matrix. So this is going to be multiplied by this pattern, plus, minus, plus, minus, plus, minus, plus, minus, plus. What is that going to do? This is going to remain the same. This is going to change sign. This is going to remain the same. This is going to change sign. It's going to remain the same. It's going to change sign. It's going to remain the same. It's going to change sign. This is going to remain the same. Okay? So, what is the result? Let me make it smaller. Plus, minus, plus. Minus, plus, minus. Plus, minus, plus. So this remains the same, so it's equal to 4. This changes to negative, so it's -5. This remains the same, -2. This becomes negative. This changes sign, so this becomes 5. This becomes, stays the same. With this change sign. This remains the same. This change sign. This remains the same. And that's step number 4. And the last step says you multiply each entry in this, which is called the adjudicate matrix. Once you get to this matrix, you multiply each term by 1 over the determinant. Well, the determinant is 1, so 1 over 1 is still 1. If you multiply everything else, everything in there, if you divide by 1, it doesn't change anything. Is that equal to the matrix that we're looking for? If we look at our matrix here, we see 4, -5, -2, 5, -6, -2, -8, 9, and 3. So that's a lot of stuff that just went down just now. So what I'm going to do is, I'm going to do another set. So I'm going to give you the original, and we're going to find the inverse matrix, okay? So using a different set of matrices. Yes. Okay, so the one that we're going to use is 1, 2, 3. Let's call this B. B equal to 1, 2, 3. Then 0, 1, 4. And then 5, 6, 0. And our goal is to find the inverse matrix. So whatever result we get, when we multiply them, we're supposed to get the identity matrix. So far, so good? So what is the inverse of this? Okay, so here we go. First step is to find the determinant. Okay, I'm going to say the determinant of B is obtained by taking 1 times the 2 by 2 matrix that is formed. When you cancel this row, cancel this column. So it is 1, 4, 6, 0. Minus 2 times Cancel this column, cancel this row, we end up with 0, 4, and 5, 0. And then plus 3 times, cancel this column, cancel this row, with 0, 1, 5, 6. When we simplify that, what do we end up with? It's going to be 1 times 0 is 0, take away minus 4 times 6 is minus 24. Then minus 2 times 0 times 0 is 0, 4 times 5 is 20, so it's minus 20. Plus 3 times 0 times 6 is 0, minus 1 times 5 is minus 5. What's that equal to? Negative 24. Negative 2 times negative 20 is plus 40. And 3 times 15 is negative 15. That looks like it's negative 39 plus 40. Again, coincidentally, we end up with a determinant of 1. Okay? So that makes our last step very easy, because when you divide by 1, it doesn't change anything. So basically you will have 3 more steps to go. Okay, so we know that the determinant of B is equal to 1. Okay, so now we're ready to go to work. Let's go. So the first step we're going to do is going to transpose the matrix. So B transpose will be equal to, the first row becomes the first column, the second row becomes the second column, the third row becomes the third column. Okay? And then we said that from there, we're going to make the matrix of minors. Okay? So we transpose. So we're going to do the matrix of minors. And from here, we're going to end up with, it's called the adjudicate matrix, which is B. We're going to need to get 6 entries. But we have to work these out individually. So the first one is take this entry, okay, cancel that row, cancel that column, we end up with 1, 6, 4, 0. Again, this 1, 6, 4, 0, and that gives us 1 times 0 is 0. That gives me negative 24. For the next entry, take this, take that. So we're left with 2, 6, 3, 0. 2 times 0 is 0. 3 times 6 is 18. So 0 take away 18. That gives me negative 18. Let me double check. So for this entry, we cancel this column, cancel this row. We have 2, 6, 3, 0, 2, 6, 3, 0, 2, 0, 0, minus 6 times 3 is 18, negative 18 is perfect. Let's go to the last one in the first row. This cancels that, so we end up with 2, 1, 3, 4. So we end up with 2 times 4 is 8, minus 3 times 1 is 3. That's equal to 5. So now we finished with the first row, let's go to the second row. Second row, start here, cross this out, cross that out, we end up with 0, 5, 4, 0. 0 times 0 is 0, minus 4 times 5 is 20. We end up with negative 20 right here. Go to the next entry, cross this out, cross that out. we're left with 1, 5, 3, 0. Let's double check. Cross this out, cross that out. 1, 5, 3, 0. 1 times 0 is 0. Minus 15 is negative 15. And then the third entry in the second row is where this is. Cross this out, cross that out. We end up with 1, 0, 3, 4. What do we end up with? 1 times 4 is 4, minus 0 times 3 is 0. So we end up with 4. So now we go to the last row. Last row, we cross out this row, cross out this column. What are we left with? 0, 5, 1, 6. And we find the determinant of this 2 by 2. We end up with AD, which is 0, minus BC, which is 5. So that gives us negative 5. We'll go to the next entry right here. Cross this out, cross that out. End up with 1, 5, 2, 6. Let's double check. This goes out 1, 5, 2, 6. Yes. 1 times 6 is 6, minus 2 times 5 is 10. That gives me negative 4. And finally, this entry, cross this out, cross that out, end up with 1, 0, 2, 1. 1, 0, 2, 1. So that gives me 1 minus 0. That's a 1. So now we need to multiply this by our positive, negative, positive, negative, positive, negative, positive, negative, positive. So this is called your matrix of minors because each is a minor. This is a minor, this is a minor. Why is it minor? Because we took the big 3 by 3 and we broke it down into 2 by 2 determinants. So these are called minors. This is a minor, this is a minor, this is a minor. So we end up with 9 minors. Okay? Now we're going to multiply. What do we end up with? This remains unchanged, so it's negative 24. This changes to 18. And this remains unchanged. This changes sign to positive 20. This remains the same. This changes to negative 4. This remains the same. This changes to 4. This remains the same. And what we're saying is this is the inverse of that because the determinant is 1. So when you divide by 1, we're going to multiply everything by 1 over the determinant. So when you divide this by 1, it doesn't change anything. So what I need to do is I need to check if when I multiply this times this, if I get the identity 3 by 3 matrix. So that is our big job right now, and then we can seal the deal. Okay, we're saying it's the inverse, so it doesn't matter what order we put it in. So we can go ahead and write negative 24, 20, negative 5, 18, negative 15, 4, and 5, negative 4, 1. Let's make sure I copied it correctly. Negative 24, 18, 5, 20, negative 15, negative 4, negative 5, 4, 1. Okay, so. Well, this is dangerous. When we multiply this, we're supposed to get the I3 matrix. That's 1, 0, 0, 0, 1, 0, 0, 0, 1. Let's go. So the first entry I'm going to work it out to the side here. So it's 1 times negative 24, 2 times 20, 3 times negative 5. Okay, so negative 24 minus 15 is negative 39, plus 40 is 1. Let's go to this entry. This first row, second column. First row, second column. So it's going to be 18. 2 times that is negative 30. 3 times that is 12. 18 plus 12 is 30. 30 take away 30 is 0. This entry is the 1, 3, 1, 3. First row, third column. 1 times 5, 5. 2 times negative 4, negative 8. 3 times 1, 3. 5 plus 3 is 8. Take away 8 is 0. Guess what? So far, so good. Keep your fingers crossed. But we can do the next one down here. So now we're into the 2, 1 entries. The second row, first column. So it's going to be 0 times negative 24 is 0. Then 1 times 20 is 20. And then 4 times negative 5 is negative 20. And that you can see is going to give us 0. Let's double check. 0 times negative 24, 0. 1 times 20, 20. 4 times negative 5, negative 20. 20 take away 20, 0. So it's going to be 2, 2 entry, second row, second column. 0 times 18, 0. 1 times negative 15, negative 15. 4 times 4, 16. Negative 15 plus 16 is 1. So we're going to go 2, 3. 2, 3, second row, third column. 0 times 5, 0. 1 times negative 4, negative 4. 4 times 1, negative 4. See, that gives us 0. So 6 out of 9, and all 6 are perfect. 3 to go. Okay, so let's erase and make some space. Okay, so now this is a 3, 1, third row, first column. Third row, first column. 5 times this gives me negative 120. 6 times this gives me positive 120. And then 0 times this gives me 0. So we know that these two cancel, gives us 0. Now we go to, this is the third row, second column. Third row, second column. 5 times 18 is 90. 6 times negative 15 is negative 90. 0 times 4 is 0. That gives me 0. 1 to go. Third row, third column. 1, 2, third row, third column. Third row, third column. 5 times 5, 25. 6 times negative 24, negative 24. 0 times 1, 0. 25 take away 24, 1. Whew. Wonderful. So, what did you see? Getting the 3 by 3 matrix is not easy. It is actually some work. quite a bit of work. As a matter of fact, if we were to go to the 4x4, you realize that it just gets more complex, but you get the gist. Good news, you have on many graphing calculators, you have the option to let the calculator derive or obtain the inverse matrix for you. So on the more sophisticated calculators that have probability, you'll be able to set up a table and then do the inverse. So that's good news for you. But now you understand what's going on in the background. You see that it's a complex concept, but it's a concept that can be done. So here we are. We discussed the Cramer's rule, and we can use Cramer's rule to solve systems of equations. And Cramer's rule basically say that you can use the determinant, strictly the determinant, to find your solutions. And then now we have just dealt with the 5 steps needed to find the inverse of a 3x3. I hope you found this helpful, and I hope this was beneficial to you. On behalf of the Brosis Foundation, we invite you to keep checking the different things that we have completed. As a matter of fact, for math, this could be about our 36th or 37th 1-hour session. So that's quite a bit of material that we have shared. So I encourage you to tell your family, tell your friends, tell anybody you know who could make use of these resources, because we're creating these just for you. Pass the word along. The more people who use them, the more encouraging it will be for us. So we have tutorials, we have these sessions in not just math, but we also have them in English. And they are all sponsored by the Brosis Foundation. It's part of what we call the Learning Together series. Okay? Enjoy the rest of your day. Thank you for visiting with us.